This video is going to walk through how to use Excel Solver to solve a linear programming problem. We've got our bakery, and we make two products, Della's Delights and Bonnie's Bourbons. And in terms of the resources required, we have three departments: mixing, filling, and baking. Della's Delight requires 30 minutes in the mixing department, no time in the filling department, and 10 minutes in the baking department. Our second product, Bonnie's Bourbon, requires 15 minutes in mixing, 15 minutes in filling, and 15 minutes in baking. And our question is, how many batches of Bonnie's Bourbon and Della's Delight should we make? We're given a little bit of additional information. We have constraints in our mixing department of 660 total minutes available per day, in the filling 270 minutes, and in baking 300 minutes. So subject to these constraints and these resource requirements, how many batches of each product should we make? We want to maximize our profit, and we're told our revenue per batch for Bonnie's is $4.75. Our variable cost per batch is $1.75, and for Della's our revenue per batch is $3.75, and our variable cost per batch is $1.25. The problem also gives us some information regarding our monthly allocated fixed cost. And recall, our allocated fixed costs, they're common costs that will go on regardless of which product we make, so we can really ignore them for this problem. Let's go ahead and start building our worksheet. First thing, let's calculate our contribution margin for each product. So our $4.75 minus our variable cost, we have a contribution margin of $300 per batch for Bonnie's and $250 for Della's Delight. Next, we're going to solve for some decision variables, these cells in blue. This is what we're eventually going to want to find answers for. But for now, let's just put one batch in for the quantities for each of these. And then let's go ahead and put together a profit function. Our profit function for Bonnie's bourbons will be equal to our quantities, 1 in this case, times our contribution margin per batch. And we have the same formula for Della's Delight. Our total profit then, if we make one batch of each, will be $250 plus $300. And we're going to want to maximize our profit. That's eventually what we're going to maximize. But we had some constraints. And our constraints were the amount of mixing, filling, and baking time we have. We have at most 660 minutes in the mixing department. We have 270 minutes in the filling department. And we have 300 minutes in the baking department. So we need to make sure our total usage of these constraints resources is less than these amounts. For Bonnie's bourbons, for every unit, and I'm going to anchor that B16, in the mixing department we use 15. Okay, and I'm going to copy that formula right down. And notice, since I anchored the B16, we're always going to B16, but I'm going to need to edit the cell reference. I want filling 15, and in the baking, again, I want 15. So those are for Bonnie's Bourbons. For Della's Delight, I've got my quantity. I'm going to anchor it times 30 for the mixing department, and I can copy that down. And again, since I've anchored my reference to the quantity, I don't need to edit that, but I do need to edit the time for the filling department for Della's Delight was 0. And then finally, for the last one, the baking time is 10 minutes. And notice, by putting in 1 for the original number of units, I can assure that I've picked up the correct contribution margins and calculated my total, and I can make sure I've picked up the correct quantities for each one of my constrained resources. And to check that, you might want to just try to double those. And Bonnie's, sure enough, changed from 15s to 30s, and Della's changed from to 60 and to 20, just like we wanted. Now, in terms of our total usage then, in the mixing department, whatever time we spend working on Bonnie's, plus whatever time we spend working on Della's. And I can copy that formula down. Now we are finally ready to use Excel's Solver to optimize our linear programming problem. So we're going to come up to our File menu or Main menu, select Data, and select Solver. If you don't have Solver, you're going to have to go to your Office button, Excel Options, and then for pick Add-ins, and you're going to want to add in your Analysis Tool Pack. OK. And let's try that one more time. Excel Options, Add-ins, Excel Add-ins down here, Analysis Tool Pack, hit Go, and make sure you've picked your Solver add-in. Hit OK. Now it's added in. So if it's up here, Data, Solver, okay, we want to maximize our profit. So we want to pick cell D18, that's where our profit is. And we could minimize it, we could whatever, but we want to maximize it. And we want to maximize it by changing these two inputs, our decision variables, our quantities of Bonnie's Bourbons and Della's Delights, subject to some constraints, and this is where we need to add our constraints. Our cell reference, our total time in the mixing department, must be less than or equal to, that's already selected, to 660. Let's add another constraint. The time in the filling department, D22, needs to be less than or equal to 200 and up. Filling department will be less than our constraint of 270. We're going to add another one. Our total time in the baking department should be less than or equal to the constraint of 300. We've selected them all. Now we can hit OK, and we can say Solve. And we've come up with our maximum answer, which is we want to maximize our profit. We want to produce 8 Bonnie Bourbons and 18 Della's Delights. And we can just hit OK, and we've got our answer.